Welcome to the Vox Pathfinder 15R channel, and today I am testing inrush current of a 5Y3GT rectifier tube. And according to the old RCA data sheet, you want a maximum hot switching transient. Well, you don't want it. This is the limit. The limit for the hot switching transient plate current per plate for a duration of 1/5 of a second is 2.2 amps max. So what I've done is, because I wanted to get rid of the ripple on the oscilloscope, you know, like that 120 hertz ripple in the top of a wave when you inject a signal and you look at it at the speaker. I paralleled in a 47 microfarad to a 16 microfarad capacitor for this first node, B1. And there's a lot of lore on the internet saying, you know, you can't go over much over 20 or 30, or you're going to get like a short condition. It's going to ruin the rectifier tube. So what I did is I got one of these handheld scopes, and let's see. What I'm going to do is I'm going to do a capture of the current, and what I'm doing is, off of the rectifier tube, I'm putting this half watt 1 ohm resistor. So, and I'm using this handheld scope as sort of like differential probes, something I couldn't do with this guy unless I got expensive probes. And it does a capture, and I can download the data if I want to, whereas I couldn't see that on this scope. The human eye wouldn't be quick enough to react. So I have this scope set to 20 millivolts per division and 2 milliseconds per division for the time. And I have it on the dot mode. And let's see. I am going to put it on a trigger, a one-time trigger. And these caps have totally discharged. So I'm going to flick on the switch. And once it does the capture, the screen freezes because it's in the DC mode, not AC. Okay, so what we have here, that first pulse is about 1, 2, 3, 4, maybe like 4.5 divisions. So that's 90 millivolts, but going across a 1 ohm resistor, so that's really 90 milliamps. But I have this, high impedance probe to protect this scope. I have it on 10 times. So we're talking, clear 0.090 amps according to this screen. And because it's on a 10 times probe, times 10, 0.9 amps for that first peak. Now watch, if I go back into the AC mode, hold a second. That's what it's doing now in real time. And I got the trigger. See, I could freeze that if I brought the trigger down, but I want it to be triggered for that one time in DC, and this is the only way to manage it. So switch it off, and then you just count down 10 seconds, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Launch. No, sorry. I have to put it on the DC trigger. Single shot. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. And this time we have 1, 2, 3, 4, close to 5. And I can download this data to make sure, but that would be if it's 5 divisions. 1, 2, 3, 4, 5, almost. That's about 1 amp for that first wave. And this is steady state. And second trigger level. I'll freeze the wave. And you can count the leading edge is almost up to that mark. So 1, 2, 3, 4. So about 4 units across. With 22 milliseconds per division. That's about 8 milliseconds. So eight milliseconds. Take the inverse. See, that's about the frequency. You know, that's 120 hertz. But if you actually did 120 hertz, inverted it, that's 8 1/3. So that could very well be 8 1/3 milliseconds. Okay, so I'm just gonna bring the trigger back up so we can do the single shot trigger. There we go. Put it into single shot mode. And what I'm going to do is this time I'm going to not go to the rectifier tube. I'm going to go to the full solid state rectification bridge. All right. 3, 2, 1, blast off. Hold on a second. Oh, that's got a more powerful thing even in the steady state. So I got to adjust the trigger level. So now it's no longer triggering. Switch it off. Single mode. Okay, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Blast off. And there you can see it goes way off. So I'd have to adjust to get the full amount of current from the solid state version. Trigger level 1 down for the AC. Okay, switch from auto to single. And we'll do another round. And the rectifier tube. It's a nice one. Again, you got 1, 2, 3, 4, close to 5. So that'd be, again, 20 millivolts per division. So that's 100 millivolts times 10. That's 1 volt. But I'm going across this 1 ohm resistor. So that's 1 amp for that initial peak. And that's for a duration of, well, you know, 8 1/3 seconds if you want to call it one period. I'd have to get RMS amperage. But yeah. So again, trigger mode. Gonna hit the trigger level 1 up. Here, single shot. Oh. Single. We'll hit it into the solid state rectifier. So it goes way off the chart compared to the the rectifier tube. Again, we'll do the rectifier tube again. And that's it, you know. 3 divisions down here, 2 up there. So it gets about 1 amp. And that's for both plates, so half an amp per plate. And the spec sheet says 2.2 max for 1/5 of a second per plate. So I guess the next thing we're going to do is I'm going to take that sucker off, and then we'll just do it with the 16 microfarads and see how that's different. All right, thanks for watching.